Okay, gang, welcome back. Happy Monday. Let's get started. So first of all, an announcement that has nothing to do with our class over here on the sideboard. You've probably heard about the Equifax data breach. It affects over 100 million Americans, and there's going to be a presentation here on campus on what it means and what you might do about it tomorrow, Tuesday at noon C208. I will be there, and if you think it's worth your time, see if you can check it out. Okay, so like I said, the quizzes go right in the green folders. I will grade them and hand them back to you next class. Everybody, this is Mary Ellen. Mary Ellen is my boss. Anybody? Really, he's my boss. I can be clear about that. Okay. Anybody that makes me look good during this period in front of Mary Ellen gets +5 on that quiz that's in the folders. All right? Work with me. You're okay. Really looking for a great class. All right, so looking at our calendars, we just turned in our first take-home quiz. The projects are coming up due real soon. A bunch of folks are making good progress on arbitration. That is due Wednesday, and then the trucks project is due on Friday. And then looking even farther ahead, Monday, a week from today, is the review for our first test, which is scheduled for the Wednesday of next week. Okay, not too early to start studying for that test. That test is going to be on everything that we have done from the start of this semester. Okay. All right, let us jump in again on page 55. Here we go. In this class, we learned 2 more derivative formulas, the product and quotient rules, and we review 3 kinds of functions, power, polynomial, and rational functions. So some new calculus stuff, and then a review of some pre-calculus stuff. So just a notation reminder, we've seen this symbol informally, d over dx, and then brackets means take the derivative of what is inside of those brackets. So we'll see that again today. All right, so number 1, we now expand our collection of derivative rules to include products and quotients of functions. Unfortunately, derivatives of products and quotients aren't as nice as derivatives of sums and differences. If they were nice, then this problem right here would be really easy. The derivative of 3x plus 2 over negative 2x minus 1 equals, maybe, I'm just going to treat numerator and denominator separately. What's the derivative upstairs? 3. Derivative downstairs? Negative 2. If life were good, that would be the answer. But it's not the answer. And it can't possibly be the answer. If you think about the graph of y equals 3x plus 2 over negative 2x minus 1, that is a complicated graph, yes? But if the derivative is constantly 3 over negative 2, constantly the same number, well, that would be a downhill line with slope negative 3 over 2, which for sure is not the graph of that function, right? So it can't possibly work. So here it says the rules, the derivative of f times g is just f prime times g prime, or the derivative of f over g is just f prime over g prime, which is what we tried up here. They're just simply not true. So put some lines through them. It doesn't work. Get real angry. Don't ever do this. It's not going to lead to, it leads to nothing good. All right. So here's the real product rule. Derivative of f times g, I'm going to skip over to the last one over here. So highlight f in yellow and g in green. And so here's my derivative rule. I've got a couple of different f's and I got a couple of different g's. And so the derivative of f times g is f times g prime plus g times f prime. That is how we take the derivative of the product of 2 functions of x. And so in plain English, I don't have these symbols memorized. What I have memorized is what's in bold here in English. It's first, so f is first, g is second. First times derivative of the second plus second times the derivative of first. That's all that I know about the product rule. So let's give it a shot. Here in number 4, it says find the derivative of this complicated thing. So I see some stuff in parentheses with x's times some other stuff in parentheses with x's. One option is to do a lot of distributing. You can do that, and it would look like just a standard polynomial, and you can go term by term because addition and subtraction work really nicely with derivatives. Let's leave it in its current form and use our newfound product rule. So this thing equals first, meaning you copy the first in its entirety in the parentheses. All of that stuff. Times the derivative of the second. So the second is this second parentheses here, and that is a polynomial, and that works really nicely with derivatives. What is the derivative in there? 8x minus 3, everyone agree? And the plus 8 doesn't contribute anything. What am I missing? Parentheses. We've got to have parentheses around this thing here. first times derivative of the second plus sign. Second, we copy the second in its entirety times the derivative of the first, the derivative of the entire thing in the first set of parentheses. Somebody we haven't heard from yet? What's that derivative? 28x cubed is good. Thank you. And that's it. So again, first times derivative of the second plus second times derivative of the first. Don't forget that plus sign in the middle. Okay, so why is it so complicated? Well, multiplying two functions together is complicated. I mean, we spent a day talking about derivative rules, and of course the first ones we talked about were the simplest ones. And so we gave you the addition and the subtraction. They were really intuitive. This one is not intuitive, but it is what it is. This is the product rule. Quotient rule is actually even worse. Here it is. I'm going to call these guys top and bottom. I'll highlight again. All my F's are going to be in yellow, and all my G's are going to be in green, but I'll call them top and bottom. So here it goes, top and bottom. Let's see, G times F prime minus F times G prime all over G squared. I don't have that formula memorized. What I do have memorized is what's here in bold. Again, top and bottom. Bottom times derivative of the top minus top times derivative of the bottom over the bottom squared. That is quotient rule, okay? Just say it a few times, it just rolls off the tongue. All right, so let's see if we can use the quotient rule down here on number 6. So this is the one that I said would be easy if we could just do a 3 on top and a -2 on the bottom. But let's try the quotient rule. So here we go. This thing equals. So again, in plain English, we start bottom times derivative of the top. So what am I copying when I say bottom? -2x minus 1 in parentheses times the derivative of the top. That is just plain 3. In this case, it doesn't need parentheses, but it usually does, and so just to be safe, I'm always going to throw it in parentheses. Okay, so that was bottom times derivative of the top. Now, big difference between this rule and the product rule. Product rule has what operation in the middle? And the product rule has addition, but the quotient rule has subtraction. It is fundamentally different. Minus. Come on in. The top, so we copy the top in its entirety times the derivative of the bottom, -2. Again, don't need parentheses here, but usually we do. And it is really easy to stop there and think you are done, but we're not done. What else do we need? So we got to square the bottom. And so because it's so easy to forget to do that at the end of this already long process, what I typically do when I have a quotient rule is start by just writing the bottom squared. I just write like a blank fraction line, and I square the bottom straight off the bat, and I leave the top blank because that's where the complicated things happen, okay? So it's easy to forget that there is a denominator. Okay, so this is good. Let's clean this up a little bit. The calculus here is done, but we'll do a little bit of algebra. So distributing up on top, a big fraction line here. We'll put the bottom anyway. No need to ever distribute on the bottom for a quotient rule. Just leave it in its squared factored form. Yeah, so we'll distribute that 3 there. So -6x minus 3. And then we'll distribute this thing here. It's easy to make a mistake. I got a subtraction here, but then I've got a -2 over here. So in my mind, the two of them just cancel each other out entirely. And it's all pluses. So that is a +2 for me. Right? So 2 distributing there makes a +6x and then a +4. Everybody with me? Absolutely. Doesn't matter which one. Ultimately, we'll end up with the same. Yeah. Okay, and then continuing to simplify up on top, I can combine terms. 6x minus 6x that just happen to cancel. -3 plus 4 is just a 1 over. And again, no need to square on the bottom. Just leave it. All right, So that's the derivative of that quotient. Any questions on the quotient rule? So in order to know when to apply the quotient rule, what you are looking for is a fraction with x's on top and x's on the bottom. I caution you, if I gave you something like 5 over x, you could use the quotient rule, but I don't think you should. We already have a rule for this guy that's much simpler. Remember the negative constant over x squared? What's the derivative of that one? Negative 5 over x squared. The quotient rule will get you there. It'll take you a lot longer, but you'll get there. And even something like this, I would not use the quotient rule. I would write this as 5x to the minus 3, and now it's a simple power rule. Quotient rule will work, but it'll take you a lot longer to get there, okay? So really what makes the quotient rule tick is x is on both top and the bottom, not just on the one. Balin. Negative 3 minus, yeah. Yeah, so I don't think it's a minus a positive 4. I think it's like it's a minus here and a minus there. They both just kind of blow up and make a positive. Yeah. Okay, and then the last piece of new notation for us for a little while is this thing right over here. It's kind of awkward using this notation to say, hey, plug in this value of x. Whereas if I said f prime of 4, you would all understand, oh, we're supposed to plug 4 into the derivative for x, right? So that is the way to say this. That is the way to say plug in x equals 4. And so let's go ahead and calculate that thing. And we'll put it right over here. This thing equals, so we're just plugging 4 into our simplified final answer. So 1 over minus 2x, nope. 1 over minus 2 times 4, minus 1. And that thing gets squared. So what does that turn out to be? $49? That's not what I see. I see 81. See 81? That's right. Right, because it's a negative 9 and the whole thing gets squared. Okay, so that's the notation. Okay, so the activity is on the next page, but I want us to do just a tiny bit of number 2 together. I'm going to get you started on this and then you'll finish it with your neighbors. So let's start number 2 together. So here's a problem from your book. It says the vertical line divides the pictured rectangle into 2 pieces. That's this rectangle here and our dotted vertical line. We want to find the value of the x coordinate that maximizes the product of the 2 areas. So imagine you take the left-hand rectangle, it's got some area. You take the right-hand rectangle, it has an area, and we're going to multiply because it says product. And we'll get one final number, right? But then if I take that x and I just shift it a little bit to the right, the left-hand rectangle gets bigger, the right-hand rectangle gets smaller, and the product probably changes a little bit, right? We're just multiplying these 2 areas. And so I'm imagining sweeping this x all the way between 0 and 1 and trying to find the biggest product of the 2 areas, okay? That's what we're after. So let's give it a shot. Area of this rectangle right here. I hear a 2x. Does that sound okay for folks? Length times width, or base times height. The bottom here is an x. The height is always 2, so 2x, that sounds good to me. The other rectangle is slightly trickier. I think what we want is a label for that distance right there. What represents this length? That's a 1 minus x, isn't it? X coordinate is the left-hand piece, and then 1 minus x is whatever is left over. So the area for this guy, 2 times 1 minus x. We buy it? Height times base. Okay, and so then what we're after here is this function, which is supposed to be the product. So I'll just call that y. And we're just writing the product of the 2 area expressions we've just come up with. So 2x on the one side, product times, right? 2, 1 minus x. Everybody okay with that? One area times the other area. So there are lots of ways we could distribute through the parentheses, and there's one particular way I want you to distribute, which will allow us to practice one of our new rules. And so all I'm going to do is distribute this second 2 through the parentheses. So 2 minus 2x. Okay. And because we're looking to maximize that function, we better take its derivative. The easiest way to take that derivative is to distribute the 2x that's in the front, and then it just looks like an ordinary polynomial. But don't ruin my fun. Use one of our new rules with that function in its current form and take the derivative, and let's see if we can finish that problem in our groups, okay? So finish this one with your neighbors, then go back up to 1 and down to 3, and then turn the page as you proceed.